Okay, in this video we're going to work on solving some compound inequalities. Make sure that you have seen the video before this on how to decide the final answer after you solve. And let's also remember that AND problems mean that we're looking for the intersection or the overlap, and OR problems mean that we're looking for all shading, or in other words, the union. Okay, so let's do 3x minus 4 less than or equal to 8 and 2x plus 5 greater than 1. Okay, so we've got this equation and this equation. So the first thing that we have to do is solve them separately, and then we can figure out the final answer using what we did in the last video. All right, so solving the one on the left, we need to get x by itself. So we're going to add 4 to both sides. We get 3x is less than 12, and we want to do the opposite again. So the opposite is divide. So we get x is less than or equal to 4. Okay, same thing for the other one. We're going to solve this. We want to get x by itself. So we do the opposite. So we do minus 5. That gives us 2x greater than negative 4. And then the opposite of multiply is divide. So we divide by 2. And we get x is greater than negative 2. Okay, now this is an and statement. That's where this comes into play. So we need to graph this and figure out where it overlaps. So our numbers are negative 2 and 4. Make sure we get those in order. Okay, we want x less than 4. So less than goes to the left. Okay, and we're less than or equal to, so that's going to be a square bracket. Square bracket there. Okay, then greater than negative 2. So from negative 2, we're going to shade to the right. And that's going to be a round bracket like that, because we're not included. And we are looking for where these two overlap. So I need orange and blue. So that's going to be here in the middle. That's where they overlap. Okay, so our final answer is negative 2 to 4, going from left to right. Not included at negative 2. It is included at positive 4. Okay, so that would be our final answer in interval notation. Okay, let's try another one. Let's say that we've got 2x plus 3 greater than or equal to 11, or x plus 5 less than 0. Okay, so the first step is the same as the last one. We need to solve each one separately. So we're going to solve the one on the left. We need to get x by itself. So we get 2x greater than or equal to 8. And then we want to do the opposite, so we divide by 2. And we get x greater than or equal to 4. Okay, solve the other one. And we get x less than 5, so we just need to subtract 5 from each side. Okay, so those are our two answers, and this is an OR scenario. So same as the last one, we're going to put it on the number line, but this time we're looking for all shading, the union. We're looking for anywhere that it's shaded. Okay, so we got to put our numbers on. We've got negative 5 and positive 4. Okay, and I'm going to do x greater than or equal to 4 in green. So that's going to be out here. And it's going to be a square bracket because it's included. And then let's do less than negative 5 in purple. So less than goes to the left. And this time it's going to be a round bracket, not included. Okay, and for OR statements, we're looking for anywhere that they're shading. So anywhere that they're shading, we go from negative infinity to negative 5. Okay, infinity is never included. We see here that 5 is not included, or you can look at the original. And then we also have 4 to infinity. We see that 4 is included, square bracket, and infinity never is. Write that a little bit better, square bracket. There we go. Okay, so that's the basic idea for that one. And then we've got one more type of compound inequality, and that is where it's actually an and statement, but it's written as one inequality. It's written as a two-sided inequality. So let's say we have -2 less than or equal to 2x plus 6 less than 14. Okay, so we're given this, it's it's all written as one inequality, so 2x plus 6 is greater than or equal to -2 and less than 14 at the same time. So it's actually an and statement, but it doesn't matter whether you remember that or not, because you can just solve it and put it on the number line. Okay, so here we want to get the x by itself, just like the other ones, okay? And so we need to move this 6 away. So if we want to subtract 6 here, now we've got to do it to all three pieces. Okay, so a little bit different from an equation because you've got to keep all the pieces balanced. All right, so we've got -8 on the left, and we've got +8 on the right. And then we're going to divide everything by 2. We're going to get -4 on the left, and we're going to get +4. Oops, I changed that. Hold on one second. I don't know where that equal sign came to. There we go. Okay, so, and we're going to get +4 on the right. Okay, so x is between -4 and +4, and we've drawn these before. So we go from -4 to +4, the shading's in between, just like the inequality looks. We are included at -4, we are not included at +4. So writing that interval, we're going to go from left to right, -4 to +4, included on the left, not included on the right. Okay, so that's another type of compound inequality, and it is an and statement, but you don't have to so much worry about that because it works itself out.